All right, in video 3, we're going to talk about our triangle congruence shortcuts in doing some proofs. And I know you guys have been missing out on our proofs, so here we go. Now, in your notes, you'll notice there are 6 examples. We're going to do examples 1, 3, and 5 in this video, and we will do examples 2, 4, and 6 tomorrow in class. If you get a hang for what we're doing in examples 1, 3, and 5 in a video, you can certainly try out 2, 4, and 6 if you want to see if you did them right as we go over them the next day in class. So the first example we're going to look at, we have been given that angle A and X are congruent. So in my picture, I'm just going to mark that information. Angle A, I'm going to put 1 arc mark on, and X, I'm going to put 1 arc mark on. B and Y, angles B and Y are congruent, so I'm going to put 2 arc marks on them. And side BC, so I'm going to put 1 congruent side marking on that, is congruent to side YZ. And so when I first look at this, I want to see, do I have any shortcut? And remember our 4 shortcuts, main shortcuts we have here that always work, are side, 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 angle, and angle, angle, side. And then remember, sometimes ASS works when we really call it HL, when our A is 90 degrees. Now, what kind of information do we have marked here? Well, we've got 2 sets of angles and a side, 2 sets of angles and a side, so it's looking like we have angle, angle, side. And it's not angle, side, angle because the side that we're talking about is not the one right in between the 2 angles. So this has angle, angle, side, the triangle on the left, and the triangle on the right has angle, angle, side. And that's one of our shortcuts. So this is going to be the easiest proof you will ever see. Will I give you something like this on, say, a quiz or a test? No, of course not. But I want to start us out with the easiest possible proof we could do here. So let me backtrack all this. And here's how we would write thus said easy proof. So let me move my picture up here. So as with any proof, we start off with our given information. So I'm just going to rewrite out this stuff. Given. And with all of that given information, we had angle, angle, side. And angle, angle, side was one of our good shortcuts. So because it was a good shortcut, we can go ahead and jump to the proof statement. We don't really have to do anything else but the given and the prove. We may conclude that triangle ABC is congruent to triangle XYZ. And how did we know those 2 triangles were congruent? By the angle, angle, side theorem. By that shortcut. It says the triangles must be the same. So we're done. That's the shortest proof you will ever see, is 2 lines, where the given information is enough information to say, yes, you have congruent triangles. So now let's do example 3. Skip 2, go to 3, where it's not going to just come out and bite us, and it's going to be done. We're going to have to do a little bit of work here. So I'm going to go ahead and write my given information here. M is the midpoint of xy. And we're also told that AX is congruent to AY. So both of these represent our given information. So the AX equals AY, I can go ahead and mark that in my picture. I know those 2 sides match up. And is there anything else I can mark in my picture from my given information? Beyond that piece, there really isn't. Now the first piece of information, that M is the midpoint of XY, let's come down here and look. So M is the midpoint of XY. Well, what does that mean is true then if M is the midpoint? Well, that would mean that XM and MY must be the same length. So we can say XM is going to be congruent to MY. And how did we know that was true? Well, we used a vocabulary term, midpoint. So we would say, by definition of midpoint, we know that this is true, that I can put 2 congruent markings on XM and 2 congruent markings on MY. So right now I've got side, side. And was side, side a good shortcut? It wasn't. It wasn't a good shortcut. Well, we used this piece in our given information. We've incorporated what that really means. And we had this piece of information. What else is there in this problem? Can we even prove that these two triangles must be the same thing? There's one more little piece here, and it uses a property that we really didn't use too much last chapter, that we will definitely use much, much more this chapter. There's something else between these two triangles, literally, that they have in common. And so if you look, do they have any angles in common? Well, no, these two angles, we know these two angles have to add up to be 180, but does that necessarily mean that they're the same, that they have to be 90 and 90? No, not necessarily. What about these two angles up here? Do we know they're the same? Not necessarily. The one thing that these two triangles have in common, if you haven't noticed, is side AM, right? They both use it. So side AM in this triangle is the same side AM in this triangle. So it's really equal to itself. So here's how we're going to write that. AM is congruent to AM. So I could put 3 congruent markings on itself, essentially. Now, what reason is this true? Why is something equal or congruent to itself? If you think back to the 3 properties that were our RST, reflexive, symmetric, and transitive, this is not symmetric, because I know some of you are thinking, oh, there's 2 letters here and 2 meant symmetric, but there's only 1 congruent sign. We're really saying that something is the same thing as itself. This is the reflexive property. And it's reflexive PC because I'm using a congruent symbol. If you wrote an equal sign, you would say PE. So now I know all 3 sides in triangle AMX match up with all 3 sides of triangle AMY. So we have side, 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 and was side, side, side a good shortcut for proving triangles had to be the same exact size and be congruent? Yes. So now we can use our proof statement and say triangle AMX is congruent to triangle AMY. And the reason is, what shortcut did we find? Side, side, side postulate. And we're done. That's it for that proof. Okay, so we had to use some definition in here. We had to use a property that we haven't used so much in the parallel line chapter, but we definitely will be using more so here. So if you notice 2 triangles have something that they share literally, like side AM here, you're going to be using the reflexive property. And so now let's look at example 5. So we've got 3 pieces of given information here. We've got some parallel sides. Ooh, we haven't messed with parallel sides before. And not only are those sides parallel, but they're also congruent. And we got a pair of congruent angles. Now, they were nice enough, they already marked all that information for us in the picture, but we still have to write it out in our proof. So we have some parallel segments, and those segments are congruent, and we got a pair of congruent angles. And again, all that was given. So now, 2 of those 3 pieces of given information, this is a set of matching sides, this is a set of matching angles. So right now we have side angle or angle side, which isn't a good shortcut. So we're almost there. We're 2/3 of the way to a shortcut. We either need to show 1 more set of sides are congruent, or 1 more set of angles are congruent, and then we would have a good shortcut. So we've already used these 2 pieces to establish that we have a side pair and an angle pair. We need to focus on the parallel lines here. And this is where some of last chapter is going to creep into this chapter. So let me mark my parallel lines here. And I'm going to extend them out just to make it a little longer so they really look like lines instead of just segments. And now we've got some possibilities for transversals. The main thing that sticks out to me, you know, if I'm already talking about these as being congruent angles, I'm probably not going to be using this as a transversal or this as a transversal. I'm probably going to use the one line where there's nothing really there. So how about AC as a transversal? Do you see any special angles that make up, remember, we're focusing on the triangles. So we need to be talking about angles in the triangle that are also related to the parallel lines. So we've already talked about E and D, so we don't need to look over there. We need to be focusing on either this angle or this angle with this angle or this angle. So do you see any kind of special angle in here? Well, okay, we'll just leave it at that. One thing I notice is, well, what about angle A and angle B? What type of angles are those? Those look like corresponding angles to me. And those are the angles we want to look at. Some of you might go, well, what about angle B in this triangle and angle C? Aren't those corresponding angles? They are, but they're not using the parallel lines. They're using EB and DC with AC as the transversal. So these are corresponding angles, but they're not using known parallel lines. So we must stick with angle A and this angle B over here, which I won't be able to call angle B because there are technically 4 different angle B's in that problem. So I can say angle A, and there's truly only one angle A here, is congruent to angle DBC or CBD. And why do I know that corresponding angles are congruent? Oh, well, from last chapter, that was the corresponding angles postulate. Because since I have parallel lines, I can use the corresponding angles postulate. And so now, if we look at our picture, and let me clear off here real quick. Clear that off. I can mark, if I really wanted to, 2 arc marks on those 2 angles I just pointed out. And now if we look at our 2 triangles here, we've got angle, side, angle, angle, side, angle. We've got a good shortcut of angle, side, angle, which is enough to say triangles are congruent. So now we get to pop down here and say triangle AEB, there we go, is congruent to triangle BDC. And what shortcut did we discover? Angle, side, angle, which was a postulate. And we're done. So you notice these proofs will be a lot shorter than the parallel line ones. And sometimes, depending on whether parallel lines are present or not, we might have to use some stuff like the corresponding angles postulate from the last chapter. So not all of last chapter is completely said and done. Some of it's going to creep into our triangle chapter. And that's all for video number 3.